Okay, so here's our Bedini Energizer so far, and I'm going to say straight up that this would have to be the biggest heap of crap I've ever built, as some of us already would have known what the results would have been using soft iron as cores. Absolute garbage. Now myself and another experimenter by the name of Grum has also built one, and we've built them to the exact plans given by John himself. As you'll see, I don't have a flywheel here, and I'm not even going to waste my time putting one on. In fact, that's as far as this project's going, just because of the results we're having so far. We have 6 strong neo magnets, which would have been more than what John would have had back in 1984. We have our 6 coils. He recommended 200 turns per coil, series connected. Both myself and Grum, I have put 225 on. I think he has put 220, 225. And the reason we've done that because some plans say 200, some say 250, so we split the difference. And so all my 6 coils are in phase with all 6 magnets. The rotor is solid aluminium. It's pretty heavy. Once you add the magnets in, you've pretty much all got a flywheel anyway. On the back side, you'll see all my series connections. I used a chocky block so I could add caps if need be, which I have tried a few value caps on there, but makes no difference at all. In fact, it actually loads the generator down a little bit more. Okay, so here you see I have a capacitor. I think you can see that. Yes, you can see that. It's only a 10,000 microfarad cap, and I have a 100 ohm half watt resistor across it to bleed it back down, because once it's going, I wanted to see how fast this cap would charge, and 10,000 microfarads is not very big, especially when we consider this little one here is 25 farads. So if the generator was any good, it would pump this thing up very, very fast, and it doesn't. Down here we have our little rectifier, so we're we're rectifying half the wave of the AC, and we're rectifying it as the magnets are leaving the coil. So that is also what John specified. So everything we have so far, our turn ratio of 225, series connected, 6 coils, 6 magnets all in phase, 12 volt permanent magnet DC motor, and this one actually draws less power than one John specified. The one he used, back then of course they weren't as efficient, was drawing 1 amp at 12 volts. This one only draws 580 milliamps, so we're nearly less than half the power he was using. So what we're going to do now is run it up, and we'll have a look, and you're probably not going to believe this. You would think, oh, that looks pretty smick, it's going to do wonders. But as Graham has also found out, and I thought he may have been making a mistake where he might have had one of the coils out of phase with the other ones, or a short or something there. The magnet's not quite lining up correctly, because he was only getting a very low voltage, and best I can do RMS is about 9.8. And like I said, we have 225 turns times 6, so that's about 1380 turns all up. One would think we'd get a lot more than that, but it is, I suspect that the soft iron cores are turning most of that energy into heat. But anyway, so we'll start it up. Be running on 12 volts, and I'll show you. All I'm going to do is take this white clip lead and touch it on the negative, what is the negative output at the moment, and we can watch on the scope as to how high and fast the voltage climbs in this cap. And like I said, that's a 100 ohm resistor across there, so it's not a very big load at all, and this output is supposed to be enough to maintain the battery, which would mean that it'd have to give the battery back more energy than what it's consuming, and it's not even close. So here we go. Okay, so we're using 12 volts. We're actually running at about 650 milliamps at the moment, fluctuating a bit. But what we're going to do now is hook the output up to this cap. We can watch on the scope. I have it set at 5 volts per division at the moment. You'll see our average voltage here, and a voltage peak to peak there. So here we go. So that's it. Best we can do is about 5.7 volts across 100 ohms. That's all it's got. Once again. .7 volts across 100 ohms. So as you can see, very dismal output. And it adds about 40 milliamps current draw to the motor. So I'll just take this 100 ohm lead down resistor off. Now a healthy battery is about 13 volts, so we're going to need at least that, or more than that, to be able to dump any energy whatsoever out of this cap into the battery. So here we go. And we just hit 13 volts. So I'll just short that cap out, dump it. I'll let you have a look at the scope. I'll zoom in a bit. Okay, that should be pretty good. So here we go once again, connecting now. .12 volts. 12.5. I'll let it keep going and see what its maximum voltage is on the output. Okay, so that looks like that's the maximum we're going to get, 13.6 volts. 13.7. So maximum output's 13.7 volts, and a decent healthy battery is 13 volts. So we've got a 0.7 volt variation, or potential difference. So we're going to be dumping 0.7 volts of a 10,000 UF cap into our battery every 30 odd seconds. So absolutely dismal. And I'm calling bullshit on this one for sure, because we've built it to specifications, the best we can find, and it's not only me. There's also another guy, as I said, Grum, who's building the same machine as per the specs, and he is getting the same results on the voltage output. So There you go. This one here is now going to be shelved because it's garbage, and we're going to go back to the big one, which had a hope in hell of working. So there you go, the proof is in the pudding. Hours and hours and hours of work, and everything is spot on, all the phase of the coils, the number of turns, a much more efficient motor. We've done everything right, and there is no way in hell that that is going to keep our run battery charged. Well guys, thanks for watching. We've learnt something from it, and yes, I'm calling bullshit on that one for sure, and I think you'll find that Grum is probably going to come up with the same results. So anyway, it was worth doing one way or the other. We know what not to do from now on, and one day I may even make my own coils, or replace the cores inside those coils with laminated steel and see if the results are any better. But I'm going to go back to the big one and keep going on that, because that has a much more efficient generator and has a lot better chance of working than this piece of garbage. Thanks for watching guys, and we'll see you next time.